Hey guys, welcome to my commercial service calculation deep dive. This is where I'm going to go through very carefully and slowly and take you step by step through every code reference and every piece of information you need to know for a general commercial service calculation. In this particular video, we're going to be going over a retail store as an example. We're going to be in the 2020 code, but rest assured, this is going to apply to pretty much all the code cycles going back like 4 or 5 probably at least, because they really don't change Article 220 very much, and when they do, they don't change it by much. So I will mention the pertinent changes from 2017 as we go along, but be sure to check with whatever your jurisdiction is using, whatever code cycle you're on, to make sure that whatever is in this video is comporting with your situation. I've developed this table to make it very easy for you to see all the information for this calculation in one shot, so you can have everything on one page and you don't have to go flipping back and forth between pages. I'm going to go ahead and go over this very quickly as an overview and let you know kind of how this table works. And then we're going to take an example and work through it step by step, because I think the best way to learn something is by actually putting it into use. So we're going to start over here in this left column. And we have our square footage of our building. That's what we take first, and we'll just put that value there. We're going to take a multiplier, apply it to our square footage, and we're going to come up with our minimum lighting load. Then we're going to take a demand factor of that minimum lighting load and come up with our lighting demand load. After that, we're going to figure out our show window lighting, our track lighting, then our sign and outline lighting. Then we're going to go to receptacle loads. We're going to figure out what that is, take our demand, and then we're going to add up all these cells here and come up with a subtotal. We're going to slide that subtotal up to this column over here, and then we're going to take any other loads, any other appliances, specific loads, as denoted in 220.14 A through E and K through M. And I've got 4 spaces here, but you may have 10 or 20 or 30 loads that you got to tally up here, and you just put their values over here and they'll be added in. Then we're going to go to kitchen equipment, get that total, then we're going to take a demand factor of it and get our kitchen equipment demand. After that, we'll take our heating and we'll have our cooling, and then we'll take our non-coincident loads, which usually is the heating and cooling that we're dealing with mainly. Take the largest of the two. After that, we're going to take the largest motor of our building, take an extra 25% of that largest motor, put it there. Then we're going to end up adding the subtotal, the other loads, the kitchen demand, the largest of the non-coincident loads, and that extra 25% of the largest motor. And that's going to give us our total building VA. Once we have that, we divide by our voltage for whatever phase we're dealing with, and that'll give us our service amps. Okay, let's get to our example. All right, our example is going to be a sporting goods store. So this falls under the retail category in commercial. So we have a 45,000 square foot building. We got 12 8-foot sections of track lighting. We've got 36 feet of show window, receptacle load, a couple of automatic doors. We've got a food niche, so a little bit of a restaurant inside this place. We have rooftop heating unit, air conditioning, 120 208 volts 3-phase is our service. So we want to find out the total calculated service load in amps. Okay, so we've got our example over here and all of our listed loads. We're going to start off talking about our branch circuit loads, because the way we start off a load calculation is basically we're totaling up all of our branch circuit loads, and those come from part 2 in Article 220. And then we go to part 3 to find out all of our demand factors that we can apply. So we're going to start in part 2 here. Branch circuit load calculations. 220.10 is our general. It says branch circuit loads shall be calculated as shown in 220.12, 14, and 16. We're going to start with the floor area. And so our square footage of our building, this tells us how we come about calculating that square footage. It says the floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, the calculated floor area should not include open porches, garages, or unused unfinished spaces not adaptable for future use. Okay, that doesn't apply to us. but the building part does. The outside dimensions of the building, that's where we get our floor area. So what we're going to do is we're going to take our 45,000 square feet from our example, and we're just going to write that in right there, 45,000. Next, 220.12 says lighting load for non-dwelling occupancies. So that's a little change from the 2017 code. And I'll talk about this a little bit when we get to the table, but they split up the dwelling occupancies and pulled them out of the table. And so now they've relabeled this just non-dwelling occupancies only. Okay, it says general. A unit load of not less than that specified in table 220.12 for non-dwelling occupancies and the floor area determined in 220.11, which we just talked about, shall be used to calculate the minimum lighting load. So what that means is we're taking the square footage from 220.11, square footage. We're going to go to table 220.12 to find our multiplier, and that's going to give us our minimum lighting load. Next sentence says motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered general lighting load. So that's easy. Any motor that's that small and connected to a circuit is figured into this calculation, and we don't have to worry about figuring that in any other place. Like when we're dealing with motors later on in the calculation, we don't have to worry about these motors that are 1/8 horsepower or less and connected to a lighting circuit. Last thing here is an informational note. It says the unit values of table 220.12 are based on minimum load conditions and 100% power factor and may not provide sufficient capacity for the installation contemplated. All that means is that sometimes you may have a unique situation where you have more than the standard lighting. Say you, for instance, this is one I've run into, is in a quilt shop. Now in quilt shops they like very bright light, lots of extra light, and this is just for their main lighting. So in that case, I would figure in extra for the extra lighting that's going into that place. Now another example may be if you have a less than 100% power factor. Say you have some less efficiency going on in whatever kind of general lighting you're using, you may want to factor in some cushion to account for that. But in most situations, this is going to be adequate just to use the number given in table 220.12. Okay, now here is table 220.12, which we were just talking about. It says general lighting loads by non-dwelling occupancy. So you've got your occupancy type on the left-hand column, and then you have the volt-amp per square foot value on the right-hand column. Just a little note about this table here. As you see next to several of these occupancy types, you have some superscript letters, and they refer you down to the notes down here. For instance, gymnasium has a superscript A, and that tells you down at A, it says armories and auditoriums are considered gymnasium type occupancies. So those would have this same multiplier as a gymnasium. So I just wrote those in my code book, armories and auditoriums, so I don't forget. I don't have to look down here every time. And I did that for each one that has a superscript letter. And as we go down for this example, we'll find retail, which has a G and H superscript. G and H says barbershops and beauty parlors and stores are considered retail occupancies. So ours is a store, therefore we would be under the retail category, and that would give us a 1.9 VA per square foot multiplier. So we'd take 1.9, we'd put our multiplier right there, we'd multiply 1.9 times 45,000, and that gives us our minimum lighting load of 85,500 VA. Now if you look down here, there is a note underneath this table that says the 125% multiplier for a continuous load as specified in 210.20a is included when using the unit loads in this table for calculating the minimum lighting load for a specified occupancy. Okay, so that's just saying that in a commercial building, your lighting is going to be on for more than 3 hours at a time in almost all cases, so you need to figure in an extra 25% when calculating that load. We're going to get into this a little bit later near the end of this calculation, so I'm not going to spend too much time on it now, but this note just tells you that that extra 25% is already included into these numbers in this column here. So we don't have to add an extra 25% at any other time regarding our minimum lighting load. I think that was a good move for them to pull the dwelling unit out of this table in this 2020 code and put it in its own section. That therefore everything here is commercial, and then they can apply that extra 25% to these numbers, and we don't have to think about that ourselves, and because sometimes you forget to do that and it screws up your numbers. Okay, now that we've calculated our minimum lighting load, we're going to find out what demand factor, if any, we can apply to that. So we're going to go to part 3 for demand factors. This is, again, the standard method, feeder and service load calculations. 220.40 says, and this is the general, says the calculated load of a feeder or service shall not be less than the sum of the loads on the branch circuit supplied, as determined by part 2 of this article, which we just did, after any applicable demand factors permitted by part 3 or 4 or required by part 5 have been applied. Now part 3 is what we're just starting to get into here. Part 4 is optional method, which we're not doing in this calculation. And part 5 is farm loads, so that has no bearing on us either. Alright, there's an informational note that just tells you to go check out the back of the code book in Annex D, and you can find some examples of these calculations being done. I find these examples to be not as helpful as they could be, because it's hard to follow sometimes where they're getting their information from and why they're doing what they're doing. So it's not as clear as I think it could be and probably should be, but they do help if you want to rummage through those and see, you know, what you can get out of those examples they provide to you. Also, it says see 220.18b for the maximum load in amperes permitted for lighting units operating at less than 100% power factor. That is simply referencing loads that have some kind of a ballast or a power supply or such. They're telling you in 220.18b that you've got to add those ballasts or power supplies into your calculation. You can't just add up your lamps or your bulbs like you could with like incandescent. Because those do have a draw themselves. So you got to add all of that in to your calculation. Just to recap, it tells you that we're basically just taking our branch circuits and adding them together. However, now we're going to learn that we can apply some demand factors to those circuits sometimes. 220.42 general lighting. The demand factor specified in table 220.42 shall apply to that portion of the total branch circuit load calculated for general illumination. That is this minimum lighting load. So we can apply these demand factors to this load here. Then it says they shall not be applied in determining the number of branch circuits for general illumination. So you can't use these demand factors when you're trying to figure out your number of branch circuits for general illumination. You got to use the entire amount for that. All right, let's check out this table. Table 220.42, lighting load demand factors. You have 3 columns here. You've got your occupancy types, and then you've got your portion of lighting load to which demand factor applies, and then you have your demand factor itself, a percentage. All right, the first type is dwelling units, which doesn't apply to us. Hotels, motels, and apartment houses doesn't apply to us. Warehouses, nope. So we fall under the all others category. And what it tells us for a retail store is 100%. So we really get no demand factor at all. So over here in our table, we just write 100% here. So 85,500 VA is 85,500 VA. So we get no demand break for a retail store. Lighting demand load is 85,500 VA. Next up is show window lighting. 220.43, show window and track lighting. So A is show windows. For show window lighting, a load of not less than 200 VA per linear foot shall be included for a show window measured horizontally along its base. So it's a pretty straightforward calculation. You take whatever linear length of show windows you have in your building and you just take 200 VA per linear foot. So down here we have show window lighting, 200 VA per linear foot. Now let's see, we've got 36 feet of show window. So we're going to take 36 feet times 200 VA and we get 7,200 VA. However, we got to always remember back in table 220.12 when we were getting this multiplier, there was a note at the bottom of the table that said they take into account already the continuous loads because all those were commercial applications in that table. So they already took that into consideration and we didn't have to add an extra 25%. But in this case, with show window, track, and sign and outline lighting, we have to add the extra 25% to our load. So our 200 VA times 36 feet of show window comes out to 7,200 VA. Add the 25%, we get 9,000 VA. Next one is track lighting. B up here, 220.43b says, for track lighting in other than dwelling units or guest rooms or guest suites of hotels or motels, an additional load of 150 volt amps shall be included for every 2 feet of lighting track or fraction thereof. Where multi-circuit track is installed, the load shall be considered to be divided equally between the track circuits. Quickly, we'll take this exception. If the track lighting is supplied through a device that limits the current to the track, the load shall be permitted to be calculated based on the rating of the device used to limit the current. So if you have a current limiting device, then you only have to base your calculation on the maximum limit of that device. It doesn't apply to our situation. Now back up here, so 150 VA per 2 feet of lighting track or fraction thereof. So we have 12 8-foot sections of track lighting. So that's 96 total feet. We're going to divide that by 2 because it's only every 2 feet that we're applying this to. So that gives us 48 feet that we're applying this per footage VA value to. So then we multiply by 150 VA and it gives us 7,200 VA. But again, we got to add our extra 25%. So that brings us to 9,000 VA again. So we have 9,000 VA for the show window lighting and 9,000 VA for the track lighting. Okay, next is sign and outline lighting. 220.14f tells us sign and outline lighting. Sign and outline lighting outlets shall be calculated at a minimum of 1,200 VA for each required branch circuit specified in 600.5a. All right, well, 600.5a here says required branch circuit. Each commercial building and each commercial occupancy accessible to pedestrians shall be provided with at least one outlet in an accessible location at each entrance to each tenant space for sign or outline lighting system use. The outlets shall be supplied by a branch circuit rated at least 20 amps that supplies no other load. A sign or outline lighting outlet shall not be required at entrances for deliveries, service corridors, or service hallways that are intended to be used only by service personnel or employees. All right, so basically it tells you there's a minimum requirement of one 20 amp circuit for sign or outline lighting, and that's in any commercial building and any commercial occupancy accessible to pedestrians. So that's not a choice. No matter what, if you have a commercial calculation, a commercial building, you have to put at least one 20 amp circuit in for sign and outline lighting at each entrance to each tenant space. So we got to put a minimum of 1 because every building has at least 1 entrance. Now if your building has 2 or 3 or 4 entrances, then you have to put 2, 3, or 4 accordingly. So if you're taking a test and you have a commercial calculation on a test, they're going to tell you how many entrances you have to the building, or they're going to tell you how many sign outline lighting circuits you need. If they don't and they tell you you have 1 entrance, you've got to put 1. Or if they don't tell you anything about it, you've got to put 1. But if they tell you you have 2 entrances for tenants, then that's a signal that you've got to put 2. So in our situation, we have 2 automatic entry doors. So we're going to need 2 sign and outline lighting circuits, 1 for each door. So if we need 1,200 VA per circuit, then we're going to need 2,400 VA for ours. Now 2,400 VA times our 125% gives us 3,000 VA total for our sign and outline lighting circuits. Okay, before we go on, I want to just take a minute to talk about these continuous and non-continuous loads. So I've mentioned that several times already. Now I want to show you where we find that in the code. So in 210.20a, it tells us continuous and non-continuous loads. It says Where a branch circuit supplies continuous loads, or any combination of continuous and non-continuous loads, the rating of the overcurrent device shall not be less than the non-continuous load plus 125% of the continuous load. And then there's an exception down here about an assembly, which we're not dealing with an assembly here, so I'm not going to worry about that for our calculation. But anyway, up here it tells us we have to take 125% of any continuous load. So in commercial, many of the loads will be continuous, especially lighting. So that's why we've been multiplying these 125% by these other lighting. Okay, now we're going to move on to receptacle loads. 220.44 says receptacle loads other than dwelling units. Receptacle loads calculated in accordance with 220.14H and I shall be permitted to be made subject to the demand factors given in Table 220.42 or Table 220.44. Okay, well first let's go to 220.14H and I to see what that's talking about, because that's telling us what loads we're dealing with here. 220.14H and I. H says fixed multi-outlet assemblies. Fixed multi-outlet assemblies used in other than dwelling units or the guest rooms or guest suites of hotels or motels shall be calculated in accordance with H1 or H2. For the purposes of this section, the calculation shall be permitted to be based on the portion that contains receptacle outlets. So that last sentence just means if you've got a multi-outlet assembly but there's like gaps where there are no outlets, you don't count that as footage. Okay, so it says calculated in accordance with H1, H2. So H1 says where appliances are unlikely to be used simultaneously, 5 foot or fraction thereof of each separate and continuous length shall be considered as one outlet of not less than 180 VA. Okay, so stated a little more clearly, all that is saying is that any 5-foot section, whether it's continuous or broken, shall be considered as one outlet and have a value of 180 VA. That's all that's saying. So pretty straightforward. Okay, number 2 says where appliances are likely to be used simultaneously, each 1 foot or fraction thereof shall be considered as an outlet of not less than 180 VA. So if you have outlets that are going to be serving appliances that are likely to be used at the same time, then you have to account for every single foot instead of 5 foot and apply a 180 VA value. Okay, well that doesn't apply to this calculation because we don't have any fixed multi-outlet assemblies. So now let's go on to I, and it just says receptacle outlets. Except as covered in 220.14J, which is dwelling units, doesn't apply to us, and K, which are offices, which doesn't apply to us, receptacle outlets shall be calculated at not less than 180 VA for each single or for each multiple receptacle on one yoke. Okay, so any receptacle outlet that's either 1, 2, or 3 receptacles on one yoke, those are 180 VA apiece. Now, it goes on. A single piece of equipment consisting of a multiple receptacle comprised of 4 or more receptacles shall be calculated at not less than 90 VA per receptacle. Okay, so anything 4 or more on a single piece of equipment, you have to calculate each receptacle at 90 VA. Then it says this provision shall not be applicable to the receptacle outlets specified in 210.11C1, which are small appliances, and C2, which are laundry. So that only applies to dwelling units. Okay, so in the example, it tells us we have 8100 VA receptacle load. So it's already done the calculating for us as far as counting up the receptacles and determining how many there are, and that's where they got the 8100 VA from. So now if they had just told us how many receptacles were in the store, then we'd have to take that number of receptacles, multiply by 180 VA for each receptacle on a single yoke, and we'd come up with our VA total. But they gave us that, and so we will just put receptacle loads 8100 VA. Okay, now we have a choice. And as I wrote here, we can go to table 220.44 or 220.42 if we find that's appropriate to get our demand factor, just like it said right up here. It says you can put these subject to the demand factors given in tables 220.42 or table 220.44. So how do we know which one we're going to do? Well, let's see what that means. So if we have 8100 VA, we can either apply that to this table or we can apply it to this table. So let's say we apply it to table 220.42. So in 220.42, this is our lighting load, and if we apply that 8100 to this number, that would take us back up here. Remember up here our minimum lighting load, and then we applied the 85,500 VA to our demand factor, which was 100%, so we didn't get any change up here. Well, now we'd be applying the 8100 to that 85,500, and then we take it all at 100% and we'd get a value here. So we wouldn't get a demand factor on our plugs if we use that. In fact, you're going to find that even in warehouses, you're going to get less of a demand break than if you use this table down here, which we'll talk about in a minute. So it's not worthwhile using it for a warehouse either. Now, if you had a hotel, a motel, or an apartment without cooking provisions, that's where you may want to use this table, because you get a break for the first 20,000 VA instead of 100%. You get the same 50% once you get over 20,000 up to 100,000, but then when you go over 100,000, you get a 35% demand factor, so a big break after that. So once you have bigger, larger buildings with lots of units, this is going to give you a much better demand break for your service, this chart. Okay, so now let's find out about table 220.44. In this table, we find out that we will take this 8100 and we take the first 10,000 VA at 100%. Well, in this case, we have less than 10,000, so our whole value gets taken at 100%. So again, we get no break. So whether we go with this table or this table, we don't get a break. We're taking full value for our receptacle loads because it's not that big of a load, really. 8100 is not that much for a commercial building. Okay, but if we had more than 10,000, then we would take the remainder of that at half value, 50%. And that's what I have written here. So the first 10,000 is at 100%, the remainder at 50%. So in our case, it didn't matter which table we used, but once we get over this 10,000 threshold, it does make a difference. Then this becomes the better table. So in most cases in commercial, you're going to use this table for your receptacles. I'm just going to tell you that's probably going to be the case. Unless you're doing hotels, motels, and apartments without cooking provisions, then you're probably going to want to use this table. So anyway, that's the difference for those two. So that being the case, once we have 8100 at 100%, no demand factor, then we're ready to add up our loads. So all of these bolded numbers here, we got our lighting demand load, we got our show window lighting, we got our track lighting, we got our sign and outline lighting, and then we have our receptacle loads at demand, which is 100%. We add those up and we get 114,600 VA for a subtotal. Now we're going to slide that 114,600 on up to this column over here, and we put our subtotal right there, and we're going to start the next column. Next up is other loads as applicable. So this is going to deal with loads in 220.14 A through E and K through M. And we're just going to run through these. Some are going to apply and some won't apply to us, but I want to go through each of them because whatever you may be dealing with may have these. So the first one says other loads, all occupancies. In all occupancies, the minimum load for each outlet for general use receptacles and outlets not used for general illumination shall not be less than that calculated in 220.14A through M, the loads shown being based on nominal branch circuit voltages. Okay, so anything that was not included in our general illumination, we're going to deal with now in A through M. They say, okay, there's an exception here. It says the loads of outlets serving switchboards and switching frames and telephone exchanges shall be waived from the calculations. Okay, that is going to apply to pretty much nobody most of the time. It's just kind of one of those one-off exceptions that's very specific. But it may at some point apply to you, so there it is. All right, A says specific appliances or loads. An outlet for a specific appliance or other load not covered in 220.14b through m shall be calculated based on the ampere rating of the appliance or load served. So this is just saying anything that's not covered in the next several sections here, this applies to everything else. An outlet for a specific appliance or other load, that's pretty general. It means pretty much anything. So if it doesn't apply to B through M, it's probably going to get covered here. And just tells you that it's going to be based on the ampere rating of the appliance or load served. Pretty straightforward and pretty intuitive. Okay, B. Electric dryers and electric cooking appliances in dwellings, which doesn't apply to us, and household cooking appliances used in instructional programs, which doesn't apply to us but could apply to commercial. It says load calculations shall be permitted as specified in 220.54 for electric dryers and in 220.55 for electric ranges and other cooking appliances. All right, so that's mostly for residential, but if you happen to have some kind of like a showroom or a training facility where you have household cooking appliances but they're used for like instructional programs, then this would also apply there. All right, C is motor outlets. Loads for motor outlets shall be calculated in accordance with the requirements in 430.22, 430.24, and 440.6. Now don't forget, when you're in part 2 of Article 220, you're under branch circuits. So this is applying to branch circuits right here. Now we're going to be applying them to feeder and service calcs, of course, but only because we have a requirement of adding up our branch circuits to get our feeder value, right? So 22 technically doesn't apply to us working on feeders, but 24 does, and 440.6 does. We'll talk more about that later when we get to the actual motor calculation. Okay, D, luminaires, so lighting fixtures. An outlet supplying luminaires shall be calculated based on the maximum VA rating of the equipment and lamps for which the luminaire is rated. Okay, so you got to take into account all your lamps, but also the equipment. So anything that's maybe powering up those lamps, like maybe a ballast or a power supply, got to take those loads into consideration. Now remember, we already got our general lighting taken care of. So this is not talking about you got to go through and count up all your fixtures now. No, that's already been done. This is for luminaires that are above and beyond the general lighting. So like maybe some task lighting or specialty lighting or something like that. That's what this would be referring to. Something that's outside of the general illumination. I just wanted to make that clear before we move on. All right. E, heavy-duty lamp holders. Outlets for heavy-duty lamp holders shall be calculated at a minimum of 600 VA. Okay. Gives you a very specific VA rating for each lamp holder if it's a heavy-duty lamp holder. Okay, so let's see, what do we have for loads in any of these categories? We don't have any heavy-duty lamp holders. We don't have specialty lighting that hasn't already been taken care of, like track lighting and so forth. Motors we'll talk about in just a bit. Don't have any dryers or ranges. Okay, specific appliances or loads. We do have a couple of those, or a few of them. We have two 1200 watt automatic doors. So these don't fall under any other category, so we got to put them here. And we have two automatic doors, 2400 VA, because we have two of them at 1200. And then we also have a 1400 watt hood fan. So we got to put that in here. And we'll talk about that in just a second when we get to kitchen equipment, why we're not including it in the kitchen equipment. And then the last thing we have is a 26,000 watt air conditioning unit. So we're going to put that down here. Even though it's technically under this category, I'm going to put it down here because we're going to end up comparing this to the heating in just a little bit. And it helps me remember to do that. So we're going to put that value here, 26,000 VA for the cooling. Okay, we got three sections left here. We have K through M. K is office buildings. So in office buildings, the receptacle loads shall be calculated to be the larger of 1 or 2. Number 1, the calculated load from 220.14I, which we just read, after all demand factors have been applied. So that's where it says that every receptacle, 1 through 3 on a single yoke is given a value of 180 VA each. Okay, so that's number 1. Number 2, it says or 1 volt ampere per square foot. So if we had an office building, which we don't, but if we did, we would take the square footage of the building and we'd apply a 1 volt ampere per square foot to that. So basically it's going to be the square footage of the building, that value, and we turn that into VA, and whichever one of these two is larger, we have to take it and put it in our calculation. So that's pretty straightforward. All right, but we don't have an office, so that does not apply to us. So moving on is L, other outlets. Other outlets not covered in 220.14a through K shall be calculated based on 180 VA per outlet. So if you have any other outlets that don't have any specific purpose, then it gets a 180 VA value applied to it in this calculation. So they're really just saying anything else that you have where it's an outlet, so anywhere where power can be utilized, basically, but it's not at this moment being utilized because you don't know the load, then you'll just give it a 180 VA value. All right, last one is M. It says hotel and motel occupancies. Okay, it doesn't apply to us, but we'll just kind of read it real fast. In guest rooms or guest suites of hotels and motels, the lighting and reciprocal outlets specified in 220.14 M1, M2, and M3 are included in the minimum unit load in table 220.12. No additional load calculation shall be required for such outlets. The minimum lighting load shall be determined using the minimum unit load and the floor area as determined in 220.11 for hotel and motel occupancies. Okay, this is basically verbatim almost the same thing that's talked about in section J for dwelling units. So they're just saying this pretty much the same thing applies to hotel and motel occupancies. So number 1, all the general use receptacle outlets of 20 amp rating or less, including receptacles connected to the circuits in 220.11C3 and 220.11C4, which are bath and garage areas. And then 2, it says the receptacle outlet specified in 210.52E3, which are balconies, decks, and porches. And 3, the lighting outlet specified in 210.70. So basically all the lighting outlets in the facility. So this doesn't apply to us. I'm not going to go into it, but I just wanted to read through it because that's part of this same section that we're dealing with. So we don't have anything in our example that would fall under any of these categories. So we will move on. Okay, next thing is kitchen equipment. 220.56. Kitchen equipment other than dwelling units. It shall be permissible to calculate the load for commercial electric cooking equipment, dishwasher booster heaters, water heaters, and other kitchen equipment in accordance with table 220.56. These demand factors shall be applied to all equipment that has either thermostatic control or intermittent use as kitchen equipment. These demand factors shall not apply to space heating, ventilating, or air conditioning equipment. All right, so that's key right there. This last sentence. This does not apply, meaning table 220.56 does not apply to HVAC. And that's what I put right here, excluding HVAC. So that's something that can easily be missed or forgotten when you're doing a calculation with kitchen equipment. You're basically, what it's saying is you're adding up all your loads, and then you're going to take this table and get a demand factor for those loads. So if you end up adding your HVAC equipment into these loads, that's really going to throw your numbers off because they're not supposed to be in there. So you got to remember that. No HVAC in this calculation here. Okay, let's talk about table 220.56. It says demand factors for kitchen equipment other than dwelling units. So we have our number of units of equipment over here, and then we have our demand factor over here. We have a food niche. So we have a little restaurant area in this sporting goods store. We have an oven, we have a toaster oven, we have a shake machine, dishwasher, and a fridge freezer combo. All right, so what we do, it's really very simple. Add them up. You just add up all your loads. And if you add all these loads up, you come up with 16,050 VA. And then we count up how many loads there are. In our case, we have 5. 1, 2, 3, 4, 5. So we go over to our table and we go down to 5. And with 5 units of equipment, we get a 70% demand factor. So we apply 70% to 16,050 VA, and we come up with 11,235 VA. And that is our kitchen equipment demand. So very easy, very straightforward. Now remember, we don't include our hood fan here, and that's why we took this out earlier and put it up here under our other loads. It's important we do that. Now a hood fan generally isn't that big of a load. In a commercial kitchen, it can be a big load, but a lot of times it's not that great of a load, so it wouldn't kill your calculation probably if you accidentally added it in here. But if you did your heating and your cooling, or maybe you had some, several hood fans, big ones, maybe a makeup air or whatever, then that can really change your calculation big time. So just be mindful of that. All right, next up is heating, 220.51. Fixed electric space heating. Fixed electric space heating loads shall be calculated at 100% of the total connected load. However, in no case shall a feeder or service load current rating be less than the rating of the largest branch circuit supplied. Okay, so that last sentence there, that's basically just saying that your largest branch circuit for your heater cannot exceed the size of your feeder rating. There is an exception here. And I don't think this exception really probably should be here. Maybe it should be a fine print note if anything, but it just tells you that the authority having jurisdiction can give you special permission. But that's always the case. They can always give you special permission on anything. So I think they put this here just to say that to be consistent with our calculations, then they're going to allow the authority having jurisdiction to make this provision. And you can read that. I'm not going to go through it because it doesn't apply to us and it's very specific to a situation and a location. So we'll move on. We're going to take 100% of our heating load. So heating load is 45,000 watt rooftop heating unit. We're going to put that right there, 45,000. Okay, moving on, non-coincident loads. 220.60. Where it is unlikely that 2 or more non-coincident loads will be in use simultaneously, it shall be permissible to use only the largest load or loads that will be used at one time for calculating the total load of a feeder or service. Okay, we'll come back to this next section in just a second. So all it's saying is if there are 2 loads anywhere in the building, anywhere in your calculation, if you have 2 loads that are not going to be used at the same time or are at least unlikely to be used at the same time, then you only have to take the larger of the 2. So that's pretty basic, and we do that in all calculations, whether it's a house or a multiplex or whatever. So that's pretty standard. Most of the time, it's only going to be dealing with heating and cooling. Now, if you're in a plant or some kind of a factory, yeah, you may have quite a few loads actually that are not simultaneously used, where there's an interlock that keeps one piece of equipment from operating if another one is. So that's a different situation. But in most commercial and residential situations, the heating and cooling are the only 2 that are going to fall under this category. And another note is they don't always fall under this category. Sometimes the heating and cooling can be used simultaneously. But remember, it says if it's unlikely that they'll be used simultaneously. So that's what we're going to do. We're going to take the heating and the cooling and we're going to compare them to each other because they don't, in this case, get used simultaneously. And we're going to take the largest of the 2. So the heating is much larger. We're going to take the heating and put the value right there, 45,000 VA for the largest non-coincident load. All right. Now I'm going to move on to this next thing, and then we're going to come back to this last sentence here under 220.60. Okay, we're going to go to 220.50, and we're going to find our largest motor and what we're going to do about that. 220.50 says motors. Motor loads shall be calculated in accordance with 430, 24, 25, and 26, and with 440.6 for hermetic refrigerant motor compressors. All right, so what that's telling us is in our entire calculation, out of all of our loads, we have to find the largest motor in the building. And then once we do, we have to take 25% an extra 25% of that load, that largest motor, and put that value here. So normally what that would be is the AC unit or the heat pump if it's a heat pump. It's a very big, since this is one unit, it's a very big motor, and definitely this is going to be the biggest motor in our calculation. Now being commercial, sometimes you will have other motors that are bigger, but in this case we don't. Now here's where we're going to come into a little bit of a gray area as far as understanding the intent of the code, because they have changed something. In times past, we would take the largest motor other than the cooling because we have ixnayed the cooling from the calculation. We took the larger of these two, so this isn't even part of our calculation anymore, and so we would not use this as the largest motor. We'd go find another, like the next largest motor, and use it, use the extra 25% of it. But in the 2020 code, they added this sentence here to 220.60. So let's read it. It says, where a motor is part of the non-coincident load and is not the largest of the non-coincident loads, 125% of the motor load shall be used in the calculation if it is the largest motor. Okay, now let me back up. It says, where a motor is part of the non-coincident load, which our cooling is, and is not the largest of the non-coincident loads, which our cooling is not, it's not the largest, so far we're good here. 125% of the motor load shall be used in the calculation if it is the largest motor. Now presumably that means largest motor in the building. I assume that's what they mean there. And that is the case because this cooling unit is the largest motor of the building. So if we take this at face value, we have to add 125% of the cooling to our heating because that's our non-coincident load. It's telling us we have to take 125% and add it to this other load because we've already taken this as the largest. And this is in addition to that. This is in addition to this first section here. So if that was the case, we'd be taking 32,500, adding that to our 45,000, and coming up with a really big number for our service. I do not think that that's what they meant. I don't think that was the intent behind this addition. My personal feeling is that what they're trying to do here is capture that extra 25% of the largest motor, even though we aren't taking it into consideration for this calculation. They know it's still a load on the service, a major load on the service potentially, and so they want to take that extra 25% and capture that even though it's not being used in this calculation. And I understand why they would want to do that, but I think the wording is a little bit off. I think there's a mistake here, and if they wanted to do it that way, they should have just put 25% here, not 125%. Because then that would do that very thing. That would capture that extra 25% of the AC in this case, but not 125% of it. Because that completely negates the whole non-coincident load situation. If you're going to take both of these together, and not only that, but also add 25% of this, then the whole thing gets kind of blown up. And there is no non-coincident load rule to be used here. So I really think that was their intent, that that should be 25% and not 125%. There's a lot of debate and discussion in the forums on this. Nobody knows exactly for sure. I've even put in an email to the NFPA and haven't heard back from them. I don't really expect to, but we're just gonna be dealing with this until they change it again. Now, if you're taking a test, they'll tell you what your loads are. They'll tell you what the largest motor is, and so you'll just take the information that they give you. But if this is a real world situation, if this is for a job that you're figuring this up, you better check with your inspection agency, your AHJ, because find out how they are interpreting this so that you can get through your inspection and not have any corrections. Okay, so what we did was we took 25% of the largest motor, which is cooling. So 25% of 26,000 is 6,500. So we're going to add 6,500 to 45,000. So now that we have that, we can add up all of our bolded numbers. We've got our subtotal from the first column, 114,600. We've got our automatic doors, our hood fan. We've got our kitchen demand. We have our largest non-coincident load, and we have our largest motor extra 25%. Add all those together, we come up with a total building VA of 181,135 VA. So then we find our voltage, which is 208 volt, 3-phase. We multiply 208 times the square root of 3, and then we divide 181,135 by that number, and we come up with 503 amps. And that is our service total. Okay, and here is a shot of the whole calculation in one, so you can see the whole thing put together with the example. Please feel free to still that. Go ahead and hit pause if you want. You can study that. You can take a screenshot of it and use it as an example. And here is a blank template, and I've taken the color out of it, or most of the color out of it, so that you can screenshot it, you can print it, you can use it as a worksheet or a template, or however you want to use it. Hopefully you can make some use of this and put it into practice. You can print out a bunch of these and use them every time you have a commercial service calculation to work through. Seriously though, just have at it. I'm not copywriting this or anything, so just trying to help you guys out. All right, well, thanks guys for watching. If you found it helpful, please give me a like and also subscribe to my channel. That'll help me get more videos out. The more I can get the YouTube algorithm to pick these up, more guys will see it. So please subscribe and throw me a like. Also, if there's anything else you want to see a video made of, please let me know and I'll see what I can do about getting one done. All right, thanks guys. And hey, don't forget, stay free.